Hello dear students, welcome to YourPedia. Today in this video I am going to discuss some important models for the ISRO examination from the subject control systems. From all the chapters I collected some very good questions. In this some of the questions were previously appeared in different examinations. Okay, but see from these questions we are going to learn concepts also. Let's enter into the questions. The first question is, if the open loop transfer function of a negative feedback control system is g of s into h of s is equal to k by s plus 1 whole cube, then the gain k for a closed loop pole to be at minus 1 by 2 plus j root 3 by 2 is, he is asking us, see, understand the concept carefully. He is saying that the open loop transfer function of a negative feedback system is, k by s plus 1 whole cube, and he is asking us for what value of k, gain k, this particular mentioned pole minus 1 by 2 plus j root 3 by 2 will be the root. He is asking for what value of k, saying that the gain k for which the closed loop pole be at minus 1 by 2 plus j root 3 by 2. Tell me, if any s value is a pole of particular system or transfer function, then if you substitute that s value in the characteristic equation, that characteristic equation has to satisfy. What is characteristic equation? Characteristic equation is equal to 1 plus gs into hs is equal to 0. This is the characteristic equation. Roots of this characteristic equation are called as closed loop poles, or zeros of the characteristic equation. Do not get confused between zeros of the transfer function and zeros of the characteristic equation. Zeros of this characteristic equation are also called as closed loop poles. Now this value, see, in this equation, if you substitute that s, what is that s? Minus 1 by 2 plus j root 3 by 2, it has to satisfy. Why? Because he is saying that this minus 1 by 2 plus j root 3 by 2 is the closed loop pole of the particular transfer function or system or characteristic equation, right? Now just let me, yes, yeah, observe it carefully, ma. Observe it carefully. Yeah, simple calculation. I have the transfer function, open loop transfer function. So characteristic equation is equal to 1 plus k by s plus 1 whole cube is equal to 0 at s is equal to minus 1 by 2 plus j root 3 by 2. Now from that one, k by s plus 1 whole cube is equal to minus 1. From that one, k equal to minus of s plus 1 whole cube, but I need the magnitude. So k equal to what? S plus 1 whole cube. S is nothing but minus 1 by 2. Minus 1 by 2 plus j root 3 by 2 plus 1 whole cube, its magnitude, right? Simple, just calculation. K is equal to root of imaginary part square plus real part square whole cube it is. So k is equal to root of 4 by 4 whole cube it is. Therefore k equal to 1. So the point here is, for k equal to 1, that particular s is equal to minus 1 by 2 plus j root 3 by 2 will be the root of the characteristic equation or closed loop pole of that particular system, right? Yeah, let's go to the next question, ma. Next question. What is that question? Yeah, so this is a very good question. The transfer function of a second order all pass filter or all pass system. See, so all pass filter is also called as all pass system. What is an all pass filter? For all frequencies ranging from 0 to infinity, if the transfer function magnitude is exactly same for all frequencies, then it is called as all pass filter or all pass system. Now if you see, this is, if you put s is equal to 0, this transfer function magnitude is 0. First transfer function you can take. If you put s is equal to 0, the transfer function magnitude is 0. If you put s is equal to infinity, s is nothing but j omega. See, you have to put omega value, but if you are putting omega value means s value you are substituting. So omega equal to 0, you substitute, this will be 0. For omega equal to infinity, this is going to be equal to 1. that is high pass filter. Yes, if you observe this one, for S is equal to 0, this is 0. For S is equal to infinity also, this is 0, right? S is equal to infinity also, it is 0, but in between it is going to have some finite value other than 0, therefore it is a band pass filter. It is band pass filter. You see how to check a filter, I'll tell you. See, I'm taking transfer function, first one, that is S square by S square plus AS plus B. Transfer function 1 I am taking, or option A I am taking, option A, B. This is option A. You check, see, generally we have to substitute S is equal to j omega, and we have to put the value omega 0 and omega equal to infinity. If you are putting omega, means you are putting the S value only. If you put S is equal to j0, then transfer function magnitude is 0, gain is 0. If gain is 0, means that particular frequency is allowed or denied, that particular frequency is denied. Now if you put transfer function in the transfer function S is equal to j infinity, then you are going to get it as 1. For low frequency, see, 0 is the lowest frequency, infinity is the highest frequency. For low frequency, gain is less or no gain. For high frequency, there is a very good gain, right? Means high frequencies are allowed, low frequencies are denied. High frequencies are allowed, low frequencies are denied. It is a high pass filter. Therefore, option 1 is high pass filter. Come to option 2 or option B. What is that? CS by, let me write it as transfer function is equal to CS by S square plus AS plus B. So transfer function magnitude when S is equal to J0 is equal to 0. Transfer function magnitude when you put S is equal to J infinity, this is also 0, because denominator order is S square, numerator order is S power 1. Now if you are putting S is equal to J infinity, in the denominator one S will be left. If you take common and cancel, then infinite will be, something by infinite will be 0. For low frequency, gain is not there. For high frequency, gain is not there, but in between some finite value will be there. Any finite value you substitute other than 0 and infinity in this one, you are going to get some finite value. This is a band pass filter. This is band pass filter, right? So this is also, I can say, for S is equal to 0, I need not to check. For S is equal to 0, it is going to have a gain of d by b. It is going to have a gain of d by b. For a high frequency, it is going to have a gain of, again, 1. Yes, for a gain of 1. So in between you have to check. This is not an all pass filter. See, for low frequency, gain is d by b. For high frequency, gain means transfer function. Transfer function is also called as overall gain. This is not an all pass filter. Look at the option D. Option D is important for us. You can easily conclude which one is all pass filter, right? So option D is like this, that is transfer function is equal to S square minus transfer function is equal to S square minus AS plus B, minus AS plus B. Just a minute, minus AS, I'll erase this, minus AS plus B by S square plus AS plus B. Now put S is equal to j omega and get the magnitude of the transfer function. Yeah, if I put it, yeah, j omega whole square minus j omega A plus B by j omega whole square plus j omega A plus B. Its magnitude we want, that will be minus omega square minus j omega A plus B by minus omega square plus j omega A plus B, right? So that is equal to, so transfer function magnitude at S is equal to j omega is equal to root of real square plus imaginary square. What is the real part? B minus omega square whole square plus omega square A square by, this is also root of B minus omega square whole square plus omega square A square. These two got cancelled. This is equal to 1. So both numerator and denominator both are equal. Irrespective of frequency omega, always its magnitude is constant. Therefore, it is called as all pass filter or all pass system. Option D is the answer. See, if you want to check any given filter, what kind of filter it is, check with see, that is applicable up to second order. If you are going beyond the second order, there are some other methods, but up to second order most of the questions will be from first order, second order. Okay, put s is equal to 0, s is equal to infinity, then with that 90% of the questions you will be able to solve about this top concept, that is what kind of filter it is. Read this question. This is also a very good question. Okay, he's saying that a disturbance input d of t, this kind of questions number of times has been appeared in ISRO examination and DRDO examination. Okay, previously DRDO used to recruit without gate through its own examination. In DRDO you can find this kind of questions, many questions, and it is somewhat a very good question. Okay, yeah, he's saying that a disturbance input d of t is injected into the unity feedback control system control loop shown in figure. Take the reference input r of t to be unit step. He is saying that this is the reference input, this value as u of t, and he is saying that this is the disturbance input. This system is having two inputs. Now if the disturbance is measurable, it is measurable. If the distance is measurable, its effect on the output can be minimized. He is saying that the effect of the disturbance at the output should be minimized. Means, read this statement. If the disturbance is measurable, its effect on the output can be minimized significantly. He is saying that effect of disturbance at the output is minimized, means output due to disturbance must be equal to less. Minimum possible. What is the minimum possible value? 0. So he is saying that he don't want any output significantly decreased. He is saying he don't want output due to disturbance. Yeah. Using a feed forward controller GFF of S. He is saying that this is the disturbance, this is the input. Now output, this is the output. You get the output because of the input as well as disturbance. Suppose this is the mic, I am speaking here. My voice is the input I am giving. Some other noise also will enter into the mic, but I expect at the output only my voice to be amplified but not the noise. Here also disturbance is the input, some disturbance input like noise, and there is some input, required input. These two are given to the system. Both the inputs will contribute some part to the output. He is asking output because of this disturbance should be equal to 0. Significantly reduced means it is 0. For that he is keeping some feed forward controller GFF of S. Now he is asking to eliminate the component of the output due to d of t. He is saying that to eliminate, he is asking, I do not want any output due to disturbance, and if the disturbance is this one, then GFF of j omega should be. Now for that I have to find GFF of S. Now for that, see, simple thing, output must be equal to 0. See, output is of two parts. One is, I write it as total output. In S domain only I am writing. Okay, total output in S domain is equal to output due to input R of t plus output due to disturbance. Output due to disturbance. He is asking, he want to completely eliminate this part. He is asking that he want to completely eliminate that part. Means output due to disturbance is equal to 0. What is output? Output in S domain is equal to input into transfer function in S domain. Right? Now, for the output to be equal to 0, for this output to be equal to 0, input can't be 0. Why? Input is a finite input with a function of sin t. D of t is sin t. It is not 0. If disturbance itself is 0, we need not to do this much analysis. Right? Now, to make the output equal to 0, this can't be equal to 0. Then what to do? The only option is make a transfer function is equal to 0. Find the transfer function, make that equal to 0. But that transfer function I have to take by taking the input as, what is this input? This input is disturbance input d of t. I have to take disturbance as the input, then I have to find the transfer function. Yeah. Now y of s by D of S, Laplace transform of output by Laplace transform of input is called as transfer function. Y of S by D of S is the transfer function because of this input D of S. When you're doing this one, you have to assume that R of S is equal to 0. I am applying superposition, that's all. When I am considering one input, D of t, I should not consider R of t. When I am considering R of t, I should not consider D of t. This must be equal to 0. Find it out. How many forward paths are there? So, Y of S by D of S. How many forward paths are there? This is the first forward path. The forward path gain is 1. Delta 1 is 1 plus. Second forward path is, this is the second forward path. What is that? GFF of S into 1 into S by S plus 1. So, GFF of S into 1 by S into S plus 1 by delta must be equal to 0. Must be equal to 0. Come on, I do one thing. I erase this equal to here. Some people will feel that is equal to 0. Yeah, I write this side. I write this side. This must be equal to 0. This denominator delta I am not writing. Why? Because even if you write also, this delta will go that side, then it will be equal to 0. So 1 plus GFF of S by S plus 1 is equal to 0. Plus 1 plus. I am writing it here. I am writing it here. Observe. Observe please. See, 1 plus GFF of S by S into S plus 1 is equal to 0. From this one, GFF of S is equal to minus of S into S plus 1, right? Minus of S into S plus 1. GFF of S is equal to minus of S into S plus 1. Now what is the input D of t? D of t is equal to sine t. If you compare this one with the sine omega t, omega equal to 1. I told you in the classes that you have to compare this one with the standard sinusoidal functions. A into sine of omega t plus theta. A is equal to 1, where A is the maximum magnitude and theta is equal to 0, omega equal to 1. Now, if I substitute that one in this, what I am going to get? GFF of j omega, omega is 1, that is equal to minus j1 into j1 plus 1, then its magnitude is equal to GFF of j1, its magnitude is equal to root 2, and its angle GFF of j1, its angle is minus 90 plus 45 is equal to minus 45, is equal to minus 45. Minus 45 can be written as minus pi by 4. So root 2 at an angle of minus pi by 4. Very good question, conceptual question it is. So from this question was previously asked in some examination, but what is the important thing here is to learn the concept, how to learn the concept, right? Yeah. Let's read the next question. It is previous gate question asked in ISRO and DRDO number of times, this kind of model. Okay, this is previous gate question asked in instrumentation paper long back. But here you see if you feel that this question is of not control systems, but this question falls under control systems. How we are going to solve? Let us see. Let us see. Yes, observe carefully here. Yeah. Is saying that a thermometer possessing a thermal time constant of 0.5 minute. So he is saying that tau is equal to 0.5 minutes, not seconds, it is minutes please. Is introduced in a bath where the temperature is increasing at a constant rate of 5 degrees centigrade per minute, means input is rising or temperature is rising at a rate of 5 degrees centigrade per minute, then I can say that the input R of t is equal to 5 into t. Yeah, 5 into t, this t is in minutes please. So why, when t is equal to 0, it is 0. When t is equal to 1 minute, yeah, 5 degree. He is saying that 5 degrees centigrade per minute. At a second minute, how much it should be? 10. Now if you put t is equal to 2, second minute, t is in minutes, it is 10. Right or not? Means input is a RAM. What is the input given by him? RAM. That's what we have to understand. That is a RAM input. The input which rises with a constant slope is RAM. The input which is having slope 0 but some magnitude, finite magnitude other than 0 is called as step. constant magnitude throughout the time. The input which is having constant acceleration is called as a parabolic input, right? These are our standard inputs. Okay, now the steady state error is asking about steady state error. So he is saying that he given ramp input for a type 1 system. Yeah, type 1 system. Sir, how it is type 1 system? It is he given time constant, one time constant. It is first order. Standard first order system is taken as type 1 system. See, ESS is equal to, yeah, the formula is A by kV. A is, what is A? A is the slope of the ramp by kV. What is this? See, slope of the ramp is 5. What is kV? kV is equal to limit s tends to 0 s into g of s into h of s. What is the open loop transfer function of a standard first order system? I told you in the class, that is 1 by s tau. The open loop transfer function of a standard first order system is 1 by s tau. So kV is equal to limit s tends to 0 s into, that is 1 by s tau. So this s gone, that is 1 by tau. Tau is already 0.5. Therefore 1 by 0.5, how much it is? 10 by 5, that is 2. That is 2. Then steady state error ESS is equal to A is 5 by kV is 2, that is equal to 2.5 degree centigrade. Option is B. See, if you read the question, some of you may complain that, sir, this is the question, something for measuring temperature, thermal, that question is given to us. This question strictly falls under control system, that too in third chapter, that is time response analysis in first order. Okay, if you think concept of steady state error, ramp, whether you understood the concept of ramp input or not, okay, and you remember the formula of steady state error or not, all these things will be tested in this question, right? Let's go to the next question. Yeah. The condition for stability of a closed loop system with a characteristic equation. Let's write the characteristic equation. Yeah, the characteristic equation is equal to, yeah, what is that? S cube, that is equal to S cube plus BS square plus a CS plus 1 is equal to 0. And see, with the positive coefficient is, see, he is saying that this B comma C are greater than 0, he is saying. Now I told you one shortcut, we can apply shortcut, that is internal product must be greater than external product of the coefficients. What are the internal coefficients? BC. The product of BC must be greater than AD, that is 1. So answer is BC must be greater than 1. So you can do this one with help of RH criteria also. If you want me to do, I'll do. That is very simple, RH criteria. Let me do that with this with help of RH criteria. Same answer you get. This is S cube, this is S square, this is S power 1, this is S power 0, this is 1. Yeah, 1. What is our characteristic equation? S cube plus BS square plus C. Yeah, plus C. So this is C, this is 0. This is B, this is 1, this is 0. Now this one, BC minus 1 by B, this is 0, this is 1. For a system to be stable, there should not be any sign changes in the first column of Routh array. This is plus, this is plus, this is plus. Now this also need to be plus. That is what? BC minus 1 by B must be greater than 0. So BC minus 1 must be greater than 0. So BC must be greater than 1 is the condition for the system to be stable. Let's move to the next question. Yeah, very good question. This is one of the previous gate question, but many concepts we can understand here. Don't think that, see, from instrumentation paper it is, this kind of questions were asked previously in ISRO and DRDO papers also. Here the main motto of our questions is to learn the concepts, important concepts. Yeah, without pen paper we can solve. This question can be solved in two ways, either by using stability or by using I can say root locus. With both the ways I can solve. Observe it. He's saying that the Routh-Hurwitz array is given for third order characteristic equation. Okay, this is the Routh array. Okay, now he's saying that the coefficient A, B, C and K are such that A is equal to 3, B greater than 0, K greater than 0, comma C greater than 0, and C is a function of K. Okay, the root locus of the corresponding characteristic equation is as shown in the figure, in the given figure. the value of K and C for critical stability are critically stable system or marginally stable system, both are same. I told you in the class. Critically stable system and marginally stable system both are same. Now, if a system is marginally stable, then S power 1 rho must be equal to 0 in the RH tabulation, because if a system is marginally stable, it is going to have poles on the imaginary axis. If poles are there on imaginary axis, those poles are said to be symmetric poles. How many poles? 2 poles. If 2 poles are symmetric with respect to origin, then odd power rho will be completely equal to 0. If 2 poles are symmetric with respect to origin, then S power 1 rho is symmetric with respect to origin. If 4 poles are symmetric with respect to origin, then S cube rho will be completely 0 in the RH tabulation. Now make this S power 1 rho completely equal to 0. If you do that, 6 minus K by 3 is equal to 0. That implies K equal to 6. Okay, sir, very easily we got K equal to 6. Then how to get the value of, he's asking about what? The value of K and C. The value of K and C is asking. Now you tell me, I told you this one also. First of all, write the characteristic equation. Write the characteristic equation, that is equal to S cube plus AS square plus BS plus C is equal to 0 is the characteristic equation. Yeah, S cube, next is this one, AS square plus BS plus C equal to 0. Right? Now if you observe this characteristic equation, last element of the characteristic equation is C. I told you number of times in the class that the last element of this RH tabulation is nothing but the last element of the characteristic equation. I repeat, the last element in the RH tabulation is the last element of the given characteristic equation. The given characteristic equation last element is C. The last element of the RH tabulation is K. Therefore, C is equal to K. K we already got it as 6. Therefore, C is equal to 6. 6 comma 6 is the answer. Option is A. That's all. Or in another way also, by using RH criteria you can solve. By using RH criteria also you can, not RH criteria, by using root locus also you can solve. How to solve root locus from root locus? How to solve from root locus? You see, this is the location of pole on j omega axis. How much that is? That is omega is equal to root 2. 1.414 means root 2. But omega is equal to under root of D is C by B, or under root of C by A. Yeah. Under root of A by 1 is equal to root 2. So from this one you got A equal to 2. If it is marginally stable, internal product must be equal to external product, that is AB is equal to C, A equal to 2, 2B equal to C. And if it is marginally stable, this row is equal to completely 0. You get K is equal to 6 and you get K equal to 6. So this way you can do, but the first method itself is very easy. Right? You need not to go with RH criteria, just RH tabulation is enough. With root locus also you will get the same answer. You have to solve. K equal to 6 you got. Anyhow, see if it is marginally stable. Now what is the value of K? K is equal to AB into A plus B. The shortcut I told you. See, this is. In place of A there is 1. AB means K is equal to A into A plus. Yes, B is A. So this K is equal to how much it is? A plus A square, AB into A plus B, right? Not so sorry, the formula is not that. I used some other formula. Yeah, see, if this way is there, the value of K is we have to find that value. Just allow me a moment, I'll do that. S cube plus AS square plus BS plus C is equal to 0. Now the value of K for which the system is marginally stable we have to find. The value of K for which the system is marginally stable I have to find. How to find? Yes, that is very simple by using again RH tabulation. So AB is equal to C. Yeah, the condition for the system to be stable is to be marginally stable is, yeah, AB is equal to C. AB is equal to C. This is the condition I have already. Now C is saying that C is a function of K. We have 2B is equal to C and K equal to 6. So from RH tabulation we understood that K equal to 6. You need not to do. Yeah, From RC tabulation we understood that k equal to 6, you need not to do. If he is asking to find the a and b values also, then you have to go with this root locus. Let's go to the next question. Yeah, this is from root locus. The breakaway point of the root locus from the real axis for a closed loop, he is asking about the break point. The breakaway point of the root locus from the real axis for a closed loop system with a loop gain GSHS is equal to lies. So he is asking about the break point. We all know that the where the break point lies. For break point to be a valid break point, first of all that must lie on root locus. See, observe here carefully. We are going to apply one rule. There is at a -2 there is a pole, at a -5 there is a pole, at a -10 there is a 0, at -10 there is a 0. Now, does here breakpoint exist? No. Why? First of all, this region does not exist on root locus. Why? For a point on real axis to exist on root locus, the total number of poles and zeros existing right side to that point must be odd in number, both poles and zeros. In this region, to the right side, no poles, no zeros. 0 means even number, it does not exist. Here, in this region, I can say root locus exists. Root locus exists. Why? The total number of poles and zeros, if you stand anywhere in this region, to the right side will be odd in number. There is one pole. Therefore, root locus exists. Here again, root locus does not exist. Here again, root locus does not exist. Why? Because if you stand anywhere here in that highlighted region in black color, the total number of poles and zeros existing right side is even in number. There are 2 poles. Now again, in this region, root locus exists. In this region, root locus will exist. So break away. So those 2 poles are coming, they are meeting here, breaking away from here and breaking in here. One pole will come this way, another pole will come this way, one pole will go this way. Yes, in these 2 poles, one pole will come to 0. Now between -2 and -5, yes, there is a break point. Yes, break away point. Yeah, both are coming and breaking away. So here it is a break in. Both are coming in, right? Yeah, that is the answer between -2 and -5. Let's go to the next question. The open loop transfer function of a feedback control system is given as 1 by s plus 1 whole cube. The gain margin of the system is a very simple question. Very simple. Yeah, simple question. That is, gain margin is equal to reciprocal of the open loop transfer function. Reciprocal of open loop transfer function at s is equal to j omega pc, where omega pc is called as phase crossover frequency. At phase crossover frequency, at omega equal to omega pc, angle of j omega h of j omega must be equal to minus 180 degrees. Now observe here. Now what is the angle of that? Minus 3 into tan inverse of omega PC is equal to minus 180. So from this one you are going to get omega PC is equal to root 3 radians per second. Then gain margin is equal to reciprocal of that magnitude, root of omega PC square plus 1 whole cube by 1. Therefore gain margin is equal to root of root 3 square 3 plus 1 whole cube by 1. Therefore gain margin is equal to 8. 8 is the answer. This is direct formula based question. There is no concept to discuss, just formulas, right? Let's go to the next question. Yeah, the asymptotic Bode plot for the gain magnitude of a minimum phase system G of s is shown in figure. The transfer function is, yeah, solution, yes. So G of s is equal to, every transfer function is going to have some k. So initial slope is 0, therefore there are no poles, no zeros at the origin. The initial slope of Bode magnitude plot will tell us the number of poles or number of zeros which are present at the origin. But the initial slope is 0, means no poles, no zeros at origin. But at omega equal to 10, the slope is changed from, this is 0 dB per decade or 0 dB per octave. Yeah, at here at 10, the slope is changed from 0 to minus 20, then it will be 1 plus s by 10, 1 plus s by 10. The same slope changed from minus 20 to minus 40 at 250, then this will be 1 plus s by 250, 1 plus s by 250. Clear? 1 plus s by 250. Now, it is our duty to find the value of k. There is one hint that is given about k, that is at omega equal to, at omega before 10, the magnitude is 40 dB. See, for omega For omega, let me write, for omega less than 10, what is your transfer function? Your transfer function is approximately equal to k only. Why? Because according to Bode approximation, any pole or zero will come into picture just after its corner frequency. Now I am at omega equal to 10, I am at omega less than 10. Now this will not be there, this will not be there, only k by 1 into 1 k. Now what is the magnitude? 40 dB is equal to, I need not to write 40 dB, is equal to 20 log of my transfer function is only k. Now from this one, if you do k equal to 10, you get, not k equal to 10, k equal to 100 you get, 10 square, then only you will get 40, k square is 100. Now 100 by 1 plus s by 10 into 1 plus s by 250. Option A suits very well for the given question, simple question. Let's go to the next question. Yeah. The Bode asymptotic plot of a transfer function is given below. In the frequency range shown, the transfer function has, yeah, initial pole, see, initial slope is 0, write down, yeah, please observe it, see, at omega 1 there is a 0, 1 0, why? Slope is changed from 0 to plus 20. At omega 2, plus 20 is becoming minus 20, means how much has been added? Minus 40 is added. Who will give minus 40? 2 poles will give minus 40. Therefore, it is having 2 poles and 1 0. There are 2 poles and 1 0. The option is C. Option is C. See, good question it is. Simple, but yet it is a good question. Okay. Let's go to the next question. Yeah. The loop transfer function of a system is given by GSHS is equal to 10 into e power minus ls by s. The phase crossover frequency is 5 radians per second and the value of dead time L is. Don't worry what is dead time, all that is not required. He given OLTF, open loop transfer function, that is GSHS is equal to 10 into e power minus ls by s. Now he given gain crossover frequency is equal to 5. What is gain crossover frequency? It is a frequency at which a magnitude of the transfer function is equal to 1. Yes, he is given gain crossover frequency or phase crossover frequency. Given phase crossover frequency, sorry. Yeah. What is phase crossover frequency? Just previously itself I told you, it is the frequency at which angle of the transfer function is equal to minus 180. Now if you replace S with j omega in entire frequency response analysis, we have to replace S with the j omega, 10 into e power minus j omega L by j omega. Now angle of 10 into e power minus j omega L by j omega equal to minus 180, that implies minus 90 degrees, minus this will be e power j theta minus omega into 180 by pi s is equal to minus of 180, right? This omega L, yeah, why I did this one with 180 by pi? This is in degrees, but this omega L is in radians. If you want to convert radians into degrees, you have to multiply with 180 by pi. Now, how much is omega given? Omega given as 5. Omega is given as 5. So, let me write, yeah. Or otherwise, let's take everything in terms of, I can say like in radians. This is minus pi by 2, this 90 will be, this omega L, this is minus omega is 5 and L is equal to minus pi. So pi gone. So 5L is equal to pi by 2, therefore L is equal to pi by 10. L is equal to pi by 10, right? So L is equal to pi by 10. The answer is done, right? Let's go to the next question. Yeah, he is saying that a double integrator plant g of s is equal to k by s square, h of s is equal to 1 is to be compensated to achieve damping ratio of 0.5 and an undamped natural frequency omega n is equal to 5 radians per second. Which of the following compensation gc of s will be stable? You need not to think about zeta and omega n and all. He is asking which compensator you are selecting such a way that will stabilize the system. Look at the options. This will make the system unstable because it is already, this open loop transfer function is already having 2 poles at origin. This is going to give 1 more pole at origin, then you are going to have 3 poles at origin. There is 1 0. Therefore if you find I can say like you have to find a centroid you will get in the right half of S-plane. 2 poles will be in the right half of S-plane. This will make unstable. This will definitely make unstable. Why? Because you are going to have 1 0 in the right half of S-plane. To meet that 0, one pole will go. To meet that 0, one pole will go. This also will make the system unstable. Then the competition is between A and B only. C and D are directly eliminated. C and D will make the system directly unstable. Now what is my OLTF? OLTF is equal to K by S square into S plus 3 by S plus 9.9 with option A, and OLTF is equal to K by S square into S plus 9.9 by 3 by option B. This is option A, this is option B. Get the centroid. Centroid is equal to sum of the poles minus 9.9 minus sum of the zeros by number of poles minus number of zeros. It will be 2 minus 9.9 will be minus 6.6 you get minus 3.3. You have a centroid in the left half of S-plane. Now from this one you calculate centroid is equal to sum of the poles minus 3, sum of the zeros minus of minus 9.9 by 2. This will be plus 3.3. If your centroid is there in the right half of S-plane, then there are two asymptotes. The branches of root locus which are going to infinity will go to infinity from parallel to those asymptotes. As asymptotes in right half S-plane, definitely your branches of root locus also will enter into right half S-plane. This will make my system unstable, whereas this is making my system stable. The option is A is correct. Let's go to the next question. Yeah, good question it is. In the feedback scheme shown in figure, the time constant of the closed loop system is, first of all, get the closed loop transfer function, characteristic equation. Characteristic equation is equal to 1 plus A by 1 plus S tau into beta is equal to 0. So 1 plus S tau plus A beta is equal to 0. So that implies S tau is equal to minus of 1 plus A beta. So S is equal to minus of 1 plus A beta by tau. This is the pole. What is the time constant? It is the reciprocal of the real part of the pole which is located near to origin. Only one pole, that too real pole. Therefore, time constant is equal to magnitude of the reciprocal of the pole, that is tau by 1 plus A beta. Yeah, that is tau by 1 plus A beta. Option is D. Option is D. Let's go to the next question. Read the question. A first order system with a transfer function 1 by S plus 1 is excited by a signal 10 sin t, then its steady state output will be 10 by 10 sin t. Yeah, from that, see, input R of t is equal to 10 into sin t. So from this one, omega equal to 1. What is your transfer function? Transfer function is equal to 1 by S plus 1. If you replace S with j omega, 1 by j omega plus 1, put omega equal to 1, because my input is 1, therefore output frequency is also equal to 1. System is going to operate at a frequency of omega equal to 1. So with that you are going to get magnitude of 1 by root 2 at an angle of minus pi by 4. This is transfer function. Input is R of t is equal to 10 at an angle 0. Now what is output? Output equal to input into transfer function. Yeah, output equal to input into transfer function. Just a minute, let me take a white page. Yeah, output C of t or Y of t. Let me take it as Y of t. Y of t equal to input 10 at an angle 0 degrees into transfer function is, yes, what is the transfer function? Transfer function is 1 by root 2 at an angle of minus pi by 4, 1 by root 2 at an angle of minus pi by 4. Therefore, y of t is equal to 10 by root 2 at an angle of minus pi by 4. So, y of t is equal to 10 by root 2 sine of t minus pi by 4. Sine of t minus pi by 4, right? Go back, see. 10 by root 2 sine of t minus pi by 4, choice C is the answer. Choice C is the answer, right? Let's go to the next question. This is a very good question. This is a very good question. In fact, read the question carefully. That is, the steady state error of a unity feedback linear system with unit step input is 0.1. The steady state error of the same system for unit pulse input R of t having magnitude of 10 and a duration of 1 second as shown in figure is. He is saying that he is having a system. For that, he given unit step input, then he got an error of 0.1. Now he is saying that that fellow is going to give a pulse input of R of t. This is the pulse input of R of t. Then steady state error is equal to dash. See, simple thing. Steady state error, ESS, this is the formula. ESS is equal to limited t tends to infinity, R of t minus C of t is the basic formula. Means if I expand R of t limit t tends to infinity minus C of t limit t tends to infinity. Tell me. T tends to infinity, input itself is 0. If input is 0, output is also 0. So therefore 0 minus 0 is equal to 0. At steady state means t tends to infinity. At steady state, what is your input? That is a pulse input. That pulse input is existing only from 0 to 1 second with magnitude of 10. 0 to 1 second with magnitude of 10. Right? It is a pulse input. After 1 it is not existing at all. Therefore input is 0. If input itself is 0, there is no question of output. This way, analytically you can solve. Answer is 0. Or otherwise, see that input can be written as R of t can be written as 10 into u of t minus 10 into u of t minus 1. So R of s is equal to, if I take 10 common, 1 minus e power minus s by s. 1 minus e power minus s by s. 1 minus e power 10 into 1 minus e power minus s by s. Now, what is steady state error formula? ESS is equal to limit s tends to 0, s into R of s minus C of s. You can get. You're going to get the same answer, that is equal to 0. See, either you do with the formula or you do with I can say like this analytically, but analytical way is time saving, right? Yeah. See, with this we are done with the 15 questions, 15 very good models. We learned a lot of concepts from these 15 questions. This way, YourPedia always contributes to the students community to make a student community stronger, and we will help in achieving students good success. All the best. Thank you.